Number 24, rectangle ABCD has AB equals 3 and BC equals 2. Points E and F lie on lines AB and CD respectively, such that AE times EB equals 1 and CF times FD equals 1/2. Then the largest possible area of quadrilateral CFAE can be expressed in the form A plus root B plus root C over D for positive integers A, B, C, and D, such that B and C are not divisible by the square of any prime. What is A plus B plus C plus D? Now, first off, let's go ahead and draw ourselves this rectangle. And here we've got A, B, C, and D. And now let's pick points E and F on A, B, and C, D. They don't have to be accurate, but just so that we can envision what these points might look like. Here's E. Actually, you know what? I am going to move this. I'm going to put E here. And I'll put F here. And in this case, here is, I'll actually do this in a different color. So here is our quadrilateral CFAE. Now, notice that CFAE is going to be maximized in its area when AE and CF are as large as possible. So given our equations, let's go ahead and assign some variables. Let's go ahead and say that AE is X and CF is Y. Then EB is going to be 3 minus X, and FD is going to be 3 minus Y. And we're given that X times 3 minus X equals 1, and that Y times 3 minus Y equals 1/2. These are going to give you two quadratic equations that cannot be factors, but can be solved with a quadratic formula. To maximize our time here, I am going to go ahead and skip through those calculations. So X in this case will be equal to 3 plus or minus root 5 over 2. And Y equals 3 plus or minus root 7 over 2. Now, remember, we want to maximize X and Y without them going over 3, but neither of these possible values will go over 3. So instead of the plus or minus, we can go ahead and erase that and just, so X equals 3 plus root 5 over 2, and Y equals 3 plus root 7 over 2. Now, then our areas. Notice that the area of our desired quadrilateral is going to be the area of the full rectangle minus these two triangles that are not included in our quadrilateral. However, if we go ahead and write this out as functions of A, B, C, D, and X and Y, then what we get is that AB times BC, which is the area of our rectangle, minus 1/2 times BC times 3 minus X, which is the area of this triangle, minus 1/2 times AD, which is BC, times 3 minus Y, which is the area of this triangle. If we simplify this out, substituting in AB and BC for 3 and 2 respectively, AB times BC is 6, BC is 2, so 1/2 times BC is just 1, so minus 3 minus X, or minus the quantity 3 minus X, so minus 3 plus X, my apologies. And again, BC is 2, so 1/2 times BC is 1, and we get minus the quantity 3 minus Y, or minus 3 plus Y, which simplifies down to X plus Y as the area of our quadrilateral. And X equals 3 plus root 5 over 2, Y equals 3 plus 7 over root 2, or over 2, 3 plus root 7 over 2. Adding these together, we get 3 plus 3, which is 6, plus root 5, plus root 7 over 2. And that matches the form that we were looking for. So we're looking for the sum of these four integers in this fraction that we've got, which is 6 plus 7 plus 5 plus 2, for a final answer of 20.
This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.